That's cool. Okay, certain rules. Please feel free to put the doubts in the chat or mainly in the Excel sheet, which is easy for me to track. I guess you should be getting it. Good question. One second. And I would take all the doubts after 90 minutes of the session. We will go through all the doubts. Keep your doubts. It's not going to be easy for me to just answer all the doubts during the session. As we have close to around, you guys can see almost 200 plus participants. So, am I not audible, guys? I think some people are saying, yeah. So I think you need to increase your volume, right? Okay, you should be able to get hold of it on the YouTube channel of Futuretech. Yeah. Okay. Good evening, everyone. Let's get into the stuff. Hi, everyone. I am Vishwanath. I have 15 years of experience in the industry, right? Starting from networking, virtualization, storage, data center migrations, private cloud, public cloud solutions, and also a good experience on the automation with DevOps. I'm also having a training experience of almost 7 years, actually. I'm certified on AWS and Azure, and I do conduct training on Linux, DevOps, rarely on VMware and networking, based on the demand. So what do I do apart from this? Yeah, as I said in the previous slide, I do have an experience. So currently working as a freelancer, which gives me a great option to explore the technologies. So what we are going to cover as part of the day one, I'm going to go through the introduction to cloud, what is DevOps, why DevOps and cloud, and introduction to AWS itself. This will take up quite a bit of time, hoping that I'll cover that up in 90 minutes, 90 to 100 minutes. And the rest of the 20 minutes, I can take up all your questions. You can put it on chat, no issues. I'll make a note of it so that we can discuss that at the end of the session. So, day two. Okay, again, somebody saying audio is very low, but I don't think, Dinesh, it's a complaint because everyone else is able to hear it. 1 second. Is it better now? Okay. Is my voice more better and clear? Okay. Thank you. Great. Right. Day two, we're talking about security management. This is another piece which is very important on the cloud. So we will see some kind of demos. How do you configure it? What is the use case of it and stuff? And yeah, trusted advisor. What is it? Governance strategies. Third thing is we will go through the basics of networking. And how do you configure the networking on AWS? How do you create a machine? How do you log into it? What are the benefits of it? How flexible it is to get things done? We would go through that as part of it. And just seeing, we're just making sure the recording is on. Okay. Cool. Day 4, we have a we will go through the migration use cases. Right. Okay. Let's see what is cloud. Right. So cloud is basically why the terminology called cloud. How did the cloud terminology even come into picture today? Right. So let's try to understand that part of it. So what's cloud? Cloud is basically a paradigm shift from a typical data center. Okay, a paradigm shift from typical data center to an outsourced based data center. I repeat, it is an outsourced based data center. Okay, so just 1 minute. Sorry for the interruption. Okay, so what are the components which you need to look into the cloud? One important component is called as utility computing. Okay, so utility computing is nothing but basically saying, I want to use my computing power as if I use my electricity bill. So I pay the electricity bill only when I want to use it. I pay only for that. I don't have to pay for the complete EB board or the pole which is installed. Nothing is mine. It's all maintained by the EB guys, right? So similarly, on a similar lines, I want to pay my computing bills as a utility bill. I use it for 10 hours. I'll pay only for 10 hours, right? The next thing is the SOA. Okay, this is an overall which we are talking. We'll still get into details in a couple of minutes. We are talking about SOA, SLA, right? So these are the terminologies which cloud gets into, right? When you talk about cloud computing, the cloud gets into these kind of terminologies. So when we say cloud, what is it? What is it we are talking about? What cloud is this? Is it a new technology, or is it some kind of um, reframing the technology? So cloud is nothing but it's the existing technology, okay, packaged into something in a better manner so that it can be provided as a service. Okay, so how does this happen? So um, so there is an orchestration application on the cloud. Okay, and all the users are going to go and touch that application. And in the backend, there is an um, multiple data centers, right? Now, these data centers are all accessible by the orchestrator application, right? So now what happens? Now the users are going to come in and say, hey, there's one client who is coming in and saying, I need 50 machines. Okay. Now, this request is taken by the orchestrator application. It is given to the data center who is readily available to provision this 50 machines. Okay. Now, think this in your day-to-day life. You get into a restaurant, you have the person who takes the order, the service. There is a service, and there is server, and he or she comes and picks up the order, and that person who picks up your order is an orchestrator application in the cloud. Now that person goes to the kitchen. Your kitchen is nothing but the data centers you can correlate to. You have multiple kitchens in the backend, right? You have Chinese, South Indian, Italian. So that person is going to give the order to the kitchens, specific kitchens based on the customer's demand, right? So here the 50 machines are going to be provisioned in a specific data center if required. If not, if it is too generic, it can just be distributed across data center. So this intelligent decision can be taken by the orchestrator application. Now, once this 50 machines are provisioned, and once we have the provision systems information, the orchestrator application is going to give back that information to the client and also inform the billing system to start the billing, which means right now the customer has the information of those 50 machines, which means ideally the billing has to start. This complete process is called as cloud, right? So what is cloud? Cloud is a service. Okay, it is not just a technology. It is a service which is using the existing technology, converting that as a service. We do have data centers. It's not that we don't have a data center. We do have data centers already. Before even the cloud came in, how was things working? We were using only data center. But then this data center itself is now converted as a cloud, right? So with the help of a concept called as orchestrator application, so it is more of a service model. So I'm going to skip to the other slide. All right. So now let's go a little further and try to understand what more is cloud. So we spoke about utility computing. We spoke about SOA, but what is SOA? Service-oriented architecture. SLA, service level agreement. We'll get into the details in quite a bit. We also going to see right now, importantly, what is the properties and characteristics. Now, why is this important? This is very important because based on this, the customer decides whether I should select that cloud or not. Today, there are n number of cloud vendors. It's just not one. There are n number of cloud vendors, right? So these are the basic 5 important properties and characteristics which a cloud vendor should have, right? I have just abbreviated that as 2 amps. 2 amps is nothing but, if you see this, is 2 amps, okay? Availability, accessibility, manageability, performance, and scalability. Okay, let's go one by one.
before that, let's try to understand the central idea of it. So the idea behind the cloud is, as a customer, the customer doesn't care what kind of physical infrastructure they have, what is going on in the back end. The customer cares only about the service. Okay. Utility computing, as I said, it is going to be more of pay-as-you-go model. How much ever you use for, you're going to pay for. It is a service-oriented model. Now, what is service-oriented? As I said, it's no more a technology. Service-oriented is more of, okay, I sometimes have to go on mute for a few seconds. I keep coughing. So what is service? Basically, service-oriented is, or as simple terms as a service, is nothing but in a restaurant, things are service-based, which means you have the flexibility, you have a menu, you have a clear-cut thing saying that, okay, I pick the product, that is, I pick the food name and give it to the person who's going to take the order, or I can give it on to the counter, get a token, give it to the food counter to get my food. It's a clear, well-defined process, right? I don't need anybody help to do this itself, right? It's everywhere there. I just need to walk through and get my stuff done. So it's a well-defined, self-contained, and that is how the cloud has been defined. So I don't need, as a client, I don't need a help to go through the cloud service itself. Okay, I don't want anybody to walk through it. It is self-sustained. Maybe for complex scenarios, I may need some help to configure it. Apart from that, cloud is just not a service, it is a web service. So a web service is nothing but basically saying that whatever service as a cloud provider is going to provide, they're providing it on the web. The reason why today everything is on the web is basically saying, sorry about that. So the web is one of the easiest mean to get into any service, like a gmail.com. Gmail.com is gonna be, today everybody is trying to access gmail.com. It's flexibility, any mailing service, right? It's a web-based mail. You can access it from your iPad or tab or mobile, Android mobile, any mobile, laptops, desktop. You have the flexibility there, right? So that's where the web service come into picture. So cloud is also made sure that all the services are going to be web on web services, right? So service-oriented architecture. Service-oriented architecture is basically saying that every service in cloud is being granularly configured, very specifically configured, and it is configured such a way that I can pick and choose. So in a restaurant, when you go, you have an option to just order the idli, and you also have an option, say, to take the extra chutney, right? So that's the flexibility which you have. It's a service-oriented architecture. The restaurant guy is not going to say that, no, I'll not give you the extra chutney even if you pay me more. They will provide you. So it's not interdependent. He will not come back and say you have to take this to get that. No, that's not the case. They give you the flexibility. You might be charged extra. They give you the flexibility. That's the exact thing called as service-oriented architecture. So in the cloud, I may pick out of 10 things, I may just pick up 2 or 3, which is not interdependent, and I can easily play around or fix it together, make it work for my requirement. Service-oriented architecture. That's why it says loosely integrated suite of services. Okay, that's the term which is used. Okay, quality of service. Basically, without this, there's no cloud, right? So in quality of service, there are basically two quality. Whether you go for cloud or anywhere, this is like a basic thing, right? Customer care evaluation, technological evaluation. Going back to your restaurant story, customer care is the person who comes and takes the order. If that person is not soft enough, and even though technically the food is great, you may give a bad review saying that, hey, my experience in that restaurant was not great, even though the food was good. The person was rude. It could be the other way around. The person is very nice, the counter person is very nice, everybody spoke to very softly, but the food was very bad. Technologically, it was bad, right? So so similarly, on the cloud, customers are going to evaluate the cloud based on both the options. It's just not one. Customer care should be good. Something is not working. Yeah, it is not working. Fair enough. But at least as a customer, I should get the acknowledgement from the cloud vendor saying that, hey, don't worry, things will get resolved. We are with you. That's the confidence which we are looking at, right? Technological evaluation, yeah, it might happen. I mean, it doesn't mean that every time there could be a technical issue. That is not the right thing to do. Okay. Service level agreement. This is exactly the same as you say your rental agreements, right? Similar to that, here in the service level agreement, we go through uptime, downtime ratios. That is 99.99% uptime. That is, which means that your total uptime should be 99.99%. Okay. So system throughput is also measured. Response time. Okay, it could be the call response time or the services response time itself. Everything is going to be tracked, measured, and based on that, there's an SLA agreement which is going to be made. Now, this agreement is between the cloud vendor and the client, and whoever actually breaches the SLA, they pay penalty. Okay, just not the cloud vendor. Okay. So now moving on to the most important point on the cloud is properties and characteristics. So the first property to take up is your availability. What is availability? Data availability. I'm talking about data availability of 99.999% availability. So this is important. This is very important. And most of the cloud vendors are today able to provide you 99.999% availability. Now, what does this really mean? If you calculate in a year, okay, 99.999% availability is nothing but your almost like a 5 minutes of a downtime in a year. 5 minutes of a downtime in a year. Okay. So what is reliability? Reliability is basically saying how 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 much reliable the system is, how long the system is going to be up without getting break. Even though they have mentioned 5 minutes, it doesn't mean that every week 30 seconds the system is down, right? It is still within the SLA, but that doesn't, this kind of behavior is going to put the customer in a very bad thought. So if it is 5 minutes, maybe at one shot there is 2 to 3 minutes of downtime, but rest of the whole year it is consistently up. That's reliability. Okay. Now, how is cloud provider able to achieve this? Let's think of that part. Okay. So one important thing is fault tolerant system. What does this mean? Fault tolerant system is basically handling this characteristics. Now, what is this? No single point of failure. Okay. Say for example, in a restaurant, uh, um, they want to give continuous service to the customer, whatsoever happens. So what they'll do, they might have two different kitchens in the back end, which is completely isolated. Maybe it is 10 feet away from each other, completely isolated, different connections, different everything. That is how even on the cloud they will do it. They will have completely two different data centers, completely isolated, power, cooling, everything separate. So this way they are going to say there's no single point of failure for me. Okay, the customer's data is going to be there. Even my one data center goes down, I will manage to give it give the service to the customer from another data center. So fault detection, isolation, all these things are features which could add a lot of things into the into the characteristics. Okay. Apart from that, we are still talking about the first property. Okay. Apart from that, we have system security. System security is something where we say that uh, the customer should be able to do these four things as part of system security by themselves. That is, a reliable data protection is provided to the customer, where the customer can go and say, yeah, I'm really happy with the service. My data is protected. Okay, identity management. That is, only who owns the data can control the information and the compute resources. Okay, so application security, whatever cloud application which you're hosting, you should be able to have a secured connection to it, maybe a HTTPS connection, or maybe further you want to have double authentication connections, and making sure that things are pretty secure, right? And privacy is something, um, the data is not going to go out without your knowledge. It has been masked. Critical data are masked, and they are going to be only with the authorized user. They stay with the authorized user. These four very, very important component part of the security. This is part of the availability. Now, the reason why it is part of the availability is, if the security is compromised, definitely the availability is also compromised. So that is why the system security is a subcomponent of availability. The second important aspect, or second important property, is your accessibility. Accessibility is basically saying who all can access it, from where they can access it, and is there any restriction. So giving the flexibility of accessing from anywhere in the world, on that too on any device, is accessibility. In fact, cloud vendors are going to an extent you could access it from any browser. Now, why browser? Because every browser has their own way of working. So we have already seen that certain things does not work in certain browsers, but cloud vendors have made sure that their service, the cloud service, works on any browser, any browser. Okay. Now, there's a concept called as thin client. Now, why thin client is a option here? That's because I'm just trying to show an image of a thin client. You can just give me a second. Thin client. So this is a thin client. If you see, it is the size of a palm. If you see, it is just a very tiny machine which actually sits behind the monitor. So is this a full-blown system? You see this? Is it a full-blown system? No. It is a small, tiny machine which allows you to connect to the internet or to a remote machine, and you can start working on that remote machine, right? So that's the great flexibility here with the thin client, because you don't have to have an heavy machines within the organization for each and every developers. You can still have a simple thin client and tell the developers to connect to the cloud and start working on it. Made pretty simple. Data security is there with the help of thin client, right? The third, again, very important stuff, manageability. Manageability is basically saying that allowing the user or the customer or giving the control to the customer of these things, basically. Self-configuration, basically configure the automatic configuration of components, self-healing capability. So customers can configure it for their own resources, right? Self-optimization and self-protection. So system monitoring also comes into picture, um, a part of the manageability. So why system monitoring? Because customers are supposed to manage their own systems, and to do that, as a customer, I have to first monitor my system, understand where they are and what are they trying to do. All those things I have to understand. Is there a breach? Is there a utilization issue? All those things comes under the system monitoring. So cloud gives us a great flexibility to do my own resource monitoring stuff. And does it stop here? No, there's one more important component, which is called as billing. Now, as part of the cloud, even if you take up your mobile bills, right? Today, you have a detailed bill. Why is that detailed bill important? That gives you the flexibility, it gives you the control over your bills to do better in the next billing cycle. Similarly, cloud is also pay as you go model. So you may end up, if you're not careful, you may easily end up having 10 lakhs bill in a month. Easily. You can just say, hey, I'm trying to research on this, doing that, started 100 machines, and you forgot to switch off, right? That's very much possible. That's absolutely very much possible. You need to be very careful about it. So that's manageability. The fourth service or the fourth characteristic um, um, is basically performance. Okay, performance is saying now the customer is going to move completely from the cloud, from the on-prem to the cloud. Now, which means the customer is going to completely trust only and only the cloud vendor. There's no other choice. Okay, so which means now the customer will expect saying that I need parallel computing, I need this, I need that. So today, service providers, cloud service providers are able to provide a bit level parallelizing or data level or multi-core computer, uh, um, systematic multiprocess, GPU based, cluster computing, blah, 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 right? So this is basically your performance. So performance is taken care to an extent where the cloud provider is gonna handle everything by themselves. The customer just says, I need this. They also will provide you a load balancing stuff where say, what is load balancing? I don't want to put all the apples in a single basket. I'll put it in two different baskets. Even one basket breaks, I still have some apple for my consumption, right? Load balancing. So which means cloud providers are saying it is just not one uh, machine which you have. You can spread across your resources on multiple machines. Yeah. So that is what this means. Okay. So job scheduling. Job scheduling is basically saying uh, we can schedule the jobs so that dynamically the number of tasks can grow and shrink based on our requirement with the help of predefined workflow. So cloud gives us the flexibility of saying I can define some predefined workflows, saying, hey, 9 o'clock I want every day these many tasks to run. At 6 o'clock I want to shut down these many tasks, right? It's a predefined stuff, predefined flow, and that's a great flexibility for us because it can reduce a good amount of cost. The fifth and the most critical component or the property is scalability. There's two types of scalability here. One is called as vertical scaling and the other one is called as horizontal scaling. Okay. The vertical scaling is nothing but I have a machine. Okay. I have rented out a machine with the customer, or sorry, the service provider. I am the customer. I have a machine with 2 CPU, 4 GB RAM. I'm going to increase it for some time, say 8 CPU, 32 GB RAM. And then after 2 days, I'm going to decrease it back. So I'll be charged only for that extra time, for that extra resources, right? That is called vertical scaling, right? Horizontal scaling, great. That can be dynamic. What is dynamic? I can say based on CPU utilization, uh, increase the number of machines to this size or these many machines if the CPU utilization goes 70%. If it comes back to 25%, start deleting the machine. So there is a dynamic provisioning of the machines itself. Okay. So that is how this is achieved, dynamic provisioning. Also, there is something called as multi-tenant design. Now, what is multi-tenant design? It's basically like a PG, right? So you have a room, but there are 2 people staying. These 2 people are from 2 different worlds. They can be kept isolated, or they may talk to each other. That is their wish and will. But as a owner who's providing the PG, they would not share each other's information to each other, right? So multi-tenant is similar concept where uh, the cloud vendor is just not serving one customer. The server behind that is just not running for one customer or one organization. It is serving multiple client organizations. Okay, and this is how exactly we are able to achieve better things on the cloud, because there's a lot of sharing which is happening in the backend. So these are the 5 properties, and the benefit is reduce initial investment, capital expenditure is very less, and then apart from that, sorry, we don't have to buy large systems as a end system. We can make it pretty small. We can have a very tiny machines. Okay, so that's the first part of the introduction to cloud. Quickly, I'm moving into the virtualization part. So now we'll see why we are talking about virtualization, why, and how it is used in the cloud. So the concept of virtualization is basically saying that ability to run multiple operating systems on a single physical server. This terminology is kind of we need some more detail to understand. So let's go with the diagram. So I have a physical box. When I say a physical box, maybe a physical server. Okay, I'm not too sure how many people have seen a server. So I'm going to quickly get this rack server. Okay, so this is how a rack server looks like, and this is how a rack looks like. It's a 6 feet tall. The servers could be anywhere. You can just search for it. Yeah, this is how I've been in the data center. It's fun being there. So these are servers, but then what is virtualization? Why into virtualization? So before the virtualization, what used to happen is a developer will come back and say, hey, I need a server, or I need 5 servers to install A, B, C, D, E, F, G. And then all said and done, they can go, the 5 server is bought by the company, they will set up everything. And after 1 year, we see that the utilization of overall the 5 servers is not even 20%. But the developer said, we need this to go into production, but it's not even 20%. Now, is there a way that I can utilize the remaining 80% of that 5 servers? Understand, you see the cost of each servers, okay? It's not cheap, okay? These servers are crazy cost. So if you see this is actually a medium level server. it's costing around 3.5 lakhs. If you really go for a proper high-end server, it costs you around 25 lakhs. And 5 such servers, or even 15 lakhs, 5 such server is 60 lakhs investment for a project. Fair enough, they would have taken it from the customer, no problem. But it is not even utilized 20%, which means now the management has an issue saying that, hey, why didn't you plan better? Now the developer comes and says, we did plan better, but at the end, customer changed the requirement and it shrinked the utilization of the resources. So that's not my problem. Now, how do I put that 80% into use? Now, the CEO is going to go and get one more project and tell the developer, hey, can you dump the new project on the same 5 servers? That's not possible because right now all the 5 servers are running on Windows. The new set of 5 servers need Linux. We're stuck there again. So they end up buying another 5 servers, put it on the rack and manage it. This kind of behavior was going on from the day one for a very long time, right? This created a lot of mess. Okay, this created over provisioning, under provisioning. A lot of things happened. That is where the concept of virtualization came into picture. Now, what does virtualization say? I have a physical box. You see that rack server is a physical box. On top of that, I am not going to install the guest OS. What is the guest OS? A Linux or a Windows. I have another pick for you is to make understand this little more better. Just give me a minute. So if you see here, okay, I'm just going to focus here. Okay, so I do have a 32 core CPU, 256 GB RAM, and 1 terabyte hard disk. Okay, that's my physical server configuration. Okay, on top of that, instead of installing Linux and Windows, okay, as a typical scenario, I'm installing something called as hypervisor. And on top of this hypervisor, we're going to install the operating system Windows. Now, not just one, I can now install multiple operating system, Windows, Linux, Windows, Linux. Okay. Now, this concept, this kind of a setup is called as virtualization. Why? This hypervisor is making us possible that the underlying hardware is now shared between 4 different operating systems in this scenario with a proper resource utilization. I've given 4 core, 4 into 4 is 16 core, 32 GB into 4 is 128 GB, 250 GB into hard disk is 1 terabyte. So I still have CPU and RAM free. If I can add more disk, I may be able to add more machines called as virtual machines. Okay, this changed the whole world. Now, with such kind of project, the vendor is going to buy 5 servers, and now he can put more number of client projects on the same server. Right, this is virtualization. But why are we even talking about virtualization in today's cloud computing class? The reason is pretty simple. Only because there is a virtualization, the concept of cloud is being successful. Because I can share the infrastructure, I can squeeze the infrastructure. I don't have to provision each server for each customer dedicatedly for each machine. I can squeeze in, play around with the resource utilization. I can do a lot of things, right? So who are the vendors who are actually providing this operating system? These are the vendors: VMware, Citrix, Red Hat. This side is the operating system name. Okay. Okay, so yeah, then we'll come back to this image little later. So that's your virtualization. Okay, so hypervisor is a virtualization manager. Okay, this is the terminology which you need to remember. Benefits, of course, isolation, encapsulation, hardware independent, and portability. The last 2 points is so critical. It changed the whole game in the IT industry. So the hardware independence, so operating system which is created like the Windows or Linux or different types of Linux doesn't depend on the underlying hardware anymore. It just does not depend on the underlying hardware. And portability, I can move the virtual machine from one hardware to another hardware. These are the features which cloud took it up and said, hey, the perfect solution we have, and we are going to use virtualization to our benefit. And that is how today we have virtualization on cloud. And virtualization is one of the core component of the cloud computing, right? So, and you can have a detailed billing saying that how much of your machine is used. Only a portion of it you are using, but you will be billed only for that portion, not for the complete hardware itself. Okay? That's the flexibility virtualization gave us. Now, the next component of the introduction to cloud is 3 service models. The 3 service models are basically, let's try to see an analogy behind first 3 service models, and then let's try to understand this a little more detail. A simple analogy is you're getting into a city, you have 3 options. Either you can say, I'm going to build a new house, empty house, or live in a hotel. Okay, so you can always say building a new house is like from scratch, you're going to do that, but you have great control over the house. You know nook and corner of it. You know what has been done, how it has to be, but it is going to be expensive. But on a long run, it all makes sense, right? Empty house, you don't have time to build the structure, maybe apartment or even a villa which is ready made, but you can do anything in the interior part, right? But you cannot change the original structure, right? And the third option is you go stay in a hotel, walk in, walk out, no dependency. You just have a suitcase, and it's easy to do. Yeah, but on a long run, if you do a daily check-in into a hotel, on a long run, overall cost will be high. Remember that. So let's translating this into the cloud world. The first thing, building a new house is like an infrastructure as a service. Yeah, that's termed as infrastructure as a service. Buying an empty house and doing remodeling, re-interiors is like a platform as a service. We can correlate technically to platform as a service, and live in a hotel is like a software as a service. I don't own anything here. The data is mine. That's it. In fact, the data. So basically, if any theft happens in a hotel, and if I have kept the baggage, in fact, the hotel guys are responsible for that, right? So if somebody break through the door or window, they breach the security and come, they are responsible for getting back my items, right? So that's how it is. So let's try to understand this a little more deeper. Traditionally, customers are going to manage this, all the layers, right? Application data, runtime, middleware, right? But when it comes to cloud, the first option which we saw is infrastructure as a service. Okay, the cloud vendor is going to manage these things, which means the cloud vendor is going to manage the complete infrastructure which is required for the customer. It's just not infrastructure. Please understand carefully. The infrastructure is nothing but saying managing the networking, storage, servers, virtualization, blah, 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 everything. Okay. So the hardwares are maintained by the vendor. Customer has to just say, okay, he will maintain the operating system license. Now, what is middleware? Middleware is nothing but, say, for example, to run a to develop a .NET application, I need a .NET framework on my system. That's a middleware. Okay, a runtime is a .NET runtime. Okay, to be more precise, if I correlate to Java, JDK, Java Development Kit, is a middleware, and runtime is JRE, Java Runtime Environment, is a runtime which will help me run the application which I'm building. So OS, middleware, runtime, data, application is all maintained by the customer in infrastructure as a service, which means customer has a great control, but they still have to have a good administrative team, operations team, infrastructure team to handle the rest of the things. It's all virtual. No physical maintenance is there. It's all a virtual world, right? Platform as a service. Now, okay, who's going to go for infrastructure as a service? Companies like integrators like Capgemini or TechM, or who's going to be in a intermediate person between the customer and the cloud provider. They will say, hey, we will provision everything on the cloud for you. We will handle it for you. Don't worry about it, right? That is where the infrastructure as a service comes, because there is a lot of customization which happens, and we still have a lot of use case for infrastructure as a service today. The next thing is platform as a service, which is till the runtime, you just tell the cloud provider saying that, hey, I just need this, like provision a DB, okay? Provision, so like a LAMP stack. What is LAMP stack? This is where the diagram will come back into picture. LAMP stack is nothing but Linux, Apache, MySQL, and PHP. Okay, so I'm telling the cloud provider, hey, just install LAMP stack for me. Keep it ready. I'm a developer. I don't want to waste my time in setting up those things. Why? I'm more busy building my application, and I want to manage my data. So application and data is still managed by the customer, and if something goes wrong, cloud provider is not responsible for the data and application. Okay, they can take a backup. That's a separate service in cloud, but that's their responsibility. Now, software as a service. Okay, who's the use case for this? Platform as a service? Developers, of course. Mainly developers, developing companies. I mean, companies who's doing a lot of IT application development. These are best use case because they don't have to have an infrastructure person to maintain their OS or maintain their virtual machines. They can just go start developing. Okay. Software as a service, one of the best cool example which we have been using for the last 20 years is gmail.com. Gmail.com is a software as a service. Why? Two things. One, application and data I don't manage as a customer. I just use it. What am I using for? That's the second part. What am I using for? I'm using to send mails. I'm sending, receiving mails. I'm getting attachments. That's all it can do. Can it go search for Google Maps? No. Can it do anything else? No. It is specific to an application that is maintained by the cloud. Should I install anything on my laptop? No, I can just open up a browser and do it. So that's a SaaS model, software as a service. A typical corporate level example is a CRM tool, Salesforce. Okay. So I'm going to write, so this is about the cloud service model, and I'm going to jump into, these are little more English, which I don't want to get in. But then, yeah, software as a service, I just want to pause here. If you see the architecture, it's more saying that the end user is going to use the service through a web application or a web portal. Okay, like Ola service. So Ola service is like the end user, right? That is a software as a service, basically. It's an end application. So, okay, the fourth component in the introduction to cloud is deployment model. So deployment model, there are 4 types of deployment model, pretty straightforward actually. Sorry. So public cloud, private cloud, community cloud, and hybrid cloud, right? Public cloud is something where you access the services through the internet. Okay, that's your public cloud. Okay, compute, data service, storage services, all accessible through the internet, and this is shared between multiple customers. right? So common policies, shared services, rental infrastructure, homogeneous infrastructure, right? And you can scale it economically, no problem at all. What is private cloud? Now, this is more interesting actually in today's world. I see a lot of private cloud stories coming up with the customers where they're saying, hey, I have a data center with me. Okay. I don't want to go public cloud because it's very, very critical and I don't want to take any risk because we still see a kind of to an extent some kind of mess up which is happening when the data is moving, and if it is too critical there could be a data leak on the cloud, right? We are still seeing those issues. So if it is highly critical and highly sensitive data like military or financial data or research data, people would like to go for a private cloud. Now, how is a private cloud built? A private cloud is basically a story where you say you have your own data center and you build, uh, you set up a private cloud like you say cloud stack, open stack. You set up the whole cloud within your organization. Okay, so that's your in-house infrastructure, end-to-end control. It is costly. You're setting up a whole cloud just for you. Who's going to do this? Big companies actually, who has great amount of projects, who knows the projects are running for next 3 years, like Capgemini again, Infosys, Wipro. You name the big companies, service companies. They'll just buy and set up private cloud as well because it makes sense, because it's going to be cheaper on a long run, right? So and whom are they serving? They are going to serve it for the internal purpose only. Okay, so that's your private cloud, right? Now the other interesting fact which is coming up is a community cloud. Now assume that all the IITs in India, what do they do? Two important things. They are doing research, and of course it's a higher studies, right? The research would need a uh, lot of computing, lot of data to be stored securely. So can these guys go to a public cloud? No, it is dangerous. Can they set up a private cloud? It is too costly for them. So what they can do is all the IITs in India can come together and say, we will set up a community cloud, a common cloud within us, where people could access things from the internet, which we will control. We will control what they can access from the internet to access our website, to some of the research papers. The rest of the things we will control it locally. I mean, we'll make it more private to ourselves. And further that, every individual IITs will have isolation so that they can have control over their private data. This kind of a combination is called as community cloud, and we see a lot of people who are coming up with these kind of concepts to save money. And then of course there is an hybrid cloud. So hybrid cloud is basically today a combination of local infrastructure. We have public cloud. A customer is also looking for a private cloud, and it's just not one public cloud. This is public cloud A. This is public cloud B. We have multiple public clouds, and the user is able to access through the internet, connect through the VPN intranet, and blah blah blah. So today the customer is very interested in this, right? They want to say, not all my applications can go on public cloud. Not all applications want a private cloud. I'll do a hybrid cloud. So again, big companies, they are going on a hybrid cloud. Like the examples which I told you for private, they also have local infrastructure. They also have public cloud connectivity. They are going on a hybrid, and they are pretty much service providers, service integrators, okay, system integrators, service integrators. They are the best examples for hybrid cloud. Even banks are slowly moving into hybrid cloud. For example, ICICI's core banking system should be in that particular branch head office. That's the rule from the RBI. Nobody can change that. But ICICI also is into other things like health and insurance. So their generic information of the website can also always stay in a public cloud because it's not getting connected to the core account, right? So it is just a generic information, marketing information. Those things can stay on a public cloud, which makes it pretty easy for ICICI or any other banks to manage things. They don't have to grow their data center to manage all these things. Does it make sense? Sorry, let's stop it. So that's pretty much on the cloud ecosystem, which is the first part of today's topic, where public cloud, private cloud, community cloud, hybrid cloud can have IaaS, PaaS, and SaaS. Okay. All right. Moving on. Moving on to the next topic for the day, which is just trying to see. Okay, understanding the DevOps lifecycle. Great. So let me just open up. Okay. Okay. So let's understand what is DevOps. Okay. So why do we have DevOps, and what is basically the thought process behind it, right? So first of all, let's try to understand what is software development lifecycle. Software development lifecycle is saying that you take up the requirement, you do a design of it, you do a software development of it, do the testing of it, deploy it on the pre-prod and production deployment, do a QA of it, and then start doing, once it is on the production environment, you have an operation and maintenance. And then again, if you want to do any enhancing, do a planning of it, and then start gathering. It keeps going on. So any kind of software which is built, it doesn't mean that it is always this way. Most of the time it is this way until it comes to a phase and the customer decides, hey, no more, no more further enhancement which we are going to do. Okay. Okay. So we have been deploying applications and as a monolithic application. So what is monolithic application? Basically saying that it is deployed as a single core application itself, right? What is the disadvantage of this? That because there are n number of developers who are working on a single app, and there is a single build, test, and a release. Now, what is the issue? If at all somebody has done some changes, they have to wait for the cycle to complete, which might take a day's time. So end of the day, all the developers are sitting quiet, or maybe there are four set of developers who wants to do some changes, but they have to wait for the complete release to finish, come back, and then these set of developers will do. One important thing is this gives a great stability for the application because it is done one by one by one by one. But the problem is it is going to take a longer time, right? So now we wanted to change this monolithical application into a different model called as agile model. What does an agile model say? Agile model says that let's not use a single monster and it becomes a little pain to handle. We will break that monster into multiple pieces called as services, in fact, microservices. So now these microservices are broken down. The app is broken down into multiple services, and now it gives the great flexibility that 4 developers are working on one service. There are 6 services. Now, if there is an update which has to happen, it is going to happen on the maybe one of the service. Now, how is the delivery pipeline handled? Initially, we just had one build, then what is that, test and release. What will happen to this? I need to have multiple builds, multiple tests, and multiple release for each microservice. Great. Great for whom? Great for the developers, great in the development world, but actually it's a big issue for the operations guy or the administrators to maintain this infrastructure and making sure the build, test, and release is fine for each microservice. Because now, if somebody is going to take up AWS and DevOps course, they are going to be part of the cloud team or cloud engineer or DevOps engineer. It's their responsibility to coordinate with the developers to get that build, test, and release done. Okay, it's their responsibility, which means now it was just one pipeline. Now it's become multiple pipelines. Now assume that I have 10 such applications, which means I have 60 pipelines to maintain, 60 issues whenever it runs, and the team is the infrastructure team is going to go mad. There's no choice, right? That is how it is. Now, what if I have to do this manually? Build, test, and release is all done manually. It's again a big issue, big problem to handle, and there's a dependency on it. Great that the development is now much better, granular, much focused, and they can have better things to do, but it's now become a big headache for the infrastructure or operations team to handle it. How do I sort this issue? Okay, so the agile methodology gave us a great flexibility to break down the softwares, but now that did not solve, I mean, that also created another problem. We actually solved the problem with the help of DevOps. What is DevOps? Developers plus IT ops, DevOps. Okay, so we as the IT ops, we closely work with the development team. We are doing communication, collaboration, integration. With these things, we are able to fix a greater number of issues, and there is no gap. Initially, what used to happen? Hey, that is their problem. This is their problem. The communication gap used to be there. The process was that way. We changed the whole process of working, right? So why DevOps? The developer has this perspective. Understand the developer's perspective. They say delivery features after testing in development. They say if my testing goes through, everything is fine. Dev team may not dev systems may not be the same as the prod systems. Who's supposed to take care of the prod systems headache? The IT ops. If something goes down, the client is going to jump on the IT ops team. Developers may have a faster turnaround time with respect to the features. Maybe they are able to get the features, new features developed faster, but IT operations team is not ready to deploy it on the production system. They need more time because of some other issues, some other commitments. They have patch updates going on. It could be anything. So developers are not bothered what is happening, actually, what is their impact. Now, the ops view is their reward is to keep the systems up and running. The pre-prod and prod setup, they are supposed to keep it up and running all the time. They have a lesser turnaround time with respect to the feature deployment, testing due to large number of dev build coming their way. So they have to make sure everything is tested before it is going into the prod environment, right? So this is a gap. This is exactly the gap. So the first gap is between the product, the business guys, and the development. With the help of Agile, we fixed that. We broke that down into microservices. The second gap is between the development team and the operations team. We fixed that with the help of the DevOps approach. Now, there's no gap, right? Seamlessly, we work together to understand what is happening. There's a lot of togetherness which is coming up. And during any kind of deployment, ops team is always part of the calls for the development team. The development team are on calls with the whenever there is a critical issue with the ops team. Yeah, it's a little burden on people, but then there's a smooth sailing of application development, and that is how it should be done. So now, because of this, the structure of IT industry is completely changed. The way things, the expectation from the engineers has been changed. Initially, when I started my career, I knew only networking, and that was more than enough for me to exist in that company for almost 3 years. That's not the case today. You need to know cloud, you need to know basics of DevOps, you need to know some tools in DevOps to come to that extent and be there and be able to do certain job in your day-to-day work. Things are getting complex, things are getting much more mature, things are getting way too aggressive, right? So customers demand is increasing, expectation on the engineers are increasing, right? And that is why we are talking about DevOps today. So okay, so now what happens with dev and ops? Developers will work with ops to understand ops now has more clarity on the infra, and closely when we move from dev to test to prod, developers and operations team work together. Okay. So the top 3 challenges which we can think of, which is addressed, is one is the release management. Now, what is release management? It's understanding of the risks, dependencies, compliance issues way before the deployment, not after the deployment. Okay. Now, release and deployment coordination, tracking if there is an issue, documented process control, granular reporting, where everybody is involved, right? And deployment automation if required. So even I can automate the deployment, saying when the deployment happens in the dev environment, which is the development environment, it should automatically pick it up and put it on the QA with some approvals. And the third eye, somebody has to verify things are going fine, and if they approve, it should go automatically deploy on the prod. It can happen. There are companies who have completely automated the deployment because they have a complete clarity of the application to the granular level, and they control the complete application. If you can do that, there you can actually have a continuous integration. That's called as continuous integration, right? Release deployment automation or continuous integration. Excuse me for a minute. I'm sorry for this. Now the next question comes in is, when do you want to adopt and when not to? Okay. For critical systems, okay, okay, you will adopt for any kind of combination like an e-commerce or a cloud platform. Definitely you will go for cloud because you have a lot of scalability options, easy to scale. You have dynamics there. You can do a lot more things. When you will not go for it, if there's a mission critical application, it's a power system, it's a banking system, it's a financial sector. Right? So further, let's try to understand the DevOps lifecycle. So this is the diagram which I want you guys to focus as a DevOps lifecycle phase. Okay. So continuous development, continuous testing, integration, deployment, and monitoring. Okay. Now, this is how the flow is. As a DevOps engineer, you are responsible to coordinate this thing. You're not responsible to do these things. Planning will be done by the developer architect. Coding will be done by the developers. Build information will be given by the developers. We have to do the build. Testing will be done by us, but the testing plan will be given by the testing team. We need to coordinate to get this on a flow. Once this flow is completed, then the flow will go into the deployment. Where deployment? Here we will have usually a dev environment, and then the QA environment, and then we have the pre-prod and the prod. So it will go into the dev environment. Who's going to maintain the infrastructure for this? We. More importantly, there is an integration component. Very, very critical, because this integration service is an application which we use, and that application is supposed to be maintained by us only as an IT ops or a DevOps engineer or a cloud engineer. So our complete responsibility on the infrastructure starts from here, but we are still responsible to coordinate this, put it in a flow with the help of developers, make sure it is automated. Okay. Deployment is our responsibility, whether it is to dev, QA, pre-prod, prod, maintaining the repo, do it in a container base. So there is a new concept called as containers. We saw what is virtualization. Similarly, now there's a tinier form of virtualization called as containers, where we kind of create a tiny version of a virtual machine with all the required environments for that microservice and run it as a container. That is also part of the deploy and operate. And then we also have monitoring, where we are supposed to make sure everything is monitored. The services are monitored. If there is an issue, we have to check what has happened and get back to the developer if they need any intervention. Just to add some examples, like for planning and code, we have like Git. This is the older version. Then the Jira is for ticketing. And then for build, we have Maven, Gradle, and Gradle. For testing, we have Selenium, JUnit, and other stuff. So these are tools which are, I mean, Git is one tool which is commonly used between the developers and the DevOps engineers. And if you see on the middle one, which is integration, which is Jenkins. Now, Jenkins is the integration tool which is completely owned by the DevOps engineers. Completely owned by the DevOps engineers, right? And if you see on the right hand side, these are configuration management tools: Chef, Puppet, Salt, Ansible. There's a containerization tools, which is again part of it, which is your Docker, Kubernetes also, which is an advanced containerization tools. And then we also have monitoring tools like New Relic, NagOS, a lot of things. AWS has their own, Azure has their own, Google has their own. Now, we now have understood what is DevOps. Okay. Now the question is it a good idea to build the DevOps tools within my organization, or should it put it on cloud or any cloud, right? You can definitely go for any cloud. Now the question, furthermore, I'm going to talk about how AWS comes into picture here. Okay, that's the third topic for the day. Is it a wise thing to develop DevOps on AWS? Yes. That's because they have cool features. They have flexibility for you to give whether you want to use their inbuilt DevOps tools, which I've not listed here, but you could use their inbuilt DevOps tools like code pipeline, code build, code commit, and stuff. For Docker containers, there is something called as ECS, ECR. So you can either use these services, and it's pretty clean and neat to start working on that. Okay. Creating things on AWS is much more flexible when compared to any other service. So if somebody is really starting a cloud journey, right, I'll prefer, once again. I'll prefer definitely the AWS. So what is AWS? Why AWS? What is AWS, right? So let's look at that part of why AWS. What is it? How's the basic concepts around the AWS itself? Just getting up the slides. So AWS is done a pretty decent job, and they have been in the industry for almost like 15, 18 years now. They have been the pioneers. There's no doubt in it. That's because they get the flexibility of saying they have a great flexibility. They have done wonders. They started off where there was nobody in the industry to say this is how we should do it. They actually showed the path to everyone that okay, this is how the cloud should be. If you granularly start comparing things, most of the services you will see that other providers have almost like mirror imaged from AWS, and it's not by choice, it's by force, because customers are starting to getting comfortable with the flow of AWS, and now customer says, hey, if I want to switch over, I'm looking at similar kind of things with you. Okay, and that's where things are becoming different for the other providers. But yes, said that done. I'm not saying that AWS is the best. Azure is coming up. There's no doubt in it. Google Cloud is coming up. They have their own pros and cons. But I would still stick to AWS at any given point of time, because it's pretty easy, even as a individual who's trying to see what is going on and how do you get things done. It's pretty straightforward for me to get things done on AWS when compared to any other cloud. right? So give me just 1 minute. Okay, so AWS as a service. These are pretty much a decent amount of service. I just want you to understand what is going on. So if you see, we have identity management. Starting from infrastructure, we have region concepts. We will see these things in day 3. But then we have region concepts, availability zones, point of presence, which means it's a mini data center. Core services like compute, storage, CDN, databases, networking, and blah, blah, blah. And administrative access, we have like the usage tracking, service catalog. So if you see the app service itself, it's a platform as a service, right? So we have a lot of platform as a service. We have a lot of analytics service. The platform services have grown very large. Okay, I've just taken a very minimal and showing you things on the AWS. So this gives us a great flexibility, and as a customer, I would always like to uh, get onto AWS for my DevOps setup, which is always easy for me to set up things, right? So this is what I was saying: code deploy, code pipeline, code commit. It's all DevOps tools. DevOps resource management is there. Yeah, these are all the great flexibilities which we have. So further to this, we also, I mean, just to give you what is AWS and how things are. AWS is built on 5 pillars of well-architected framework. I've just abbreviated that as CROPS: cost, reliability, operations, performance, and security. So I just need another 5 minutes, then I'll start taking up the questions. Just bear with me for some time. So what is cost? AWS has built its own infrastructure such a way that it is cost effective. One thing, it also keeps informing the customer, saying that, hey, you are overutilizing or underutilized. You can go for this options, that options, which will save things in system, right? So that's your cost optimization. Reliability. AWS has created a reliable system where customers can confidently run their stuff. You can do a horizontal scaling. You don't have to start giving high size of the resources in the day 1. You can just go with minimal and keep changing when you want it. Operational excellence. This is one of the fantastic things which the thought process is very nice here. They have done perform operations as code. That is, if you want to deploy if you want to deploy a resource on cloud, you can do it through a code or a script, right? Which is great. This is where things changed, and now today every cloud vendor is doing this. Okay, you can do a small frequent changes, reversible changes. It's very visible, transparent. You know what you have done, and you can always be ready for failure. I mean, if there is a failure in the backend system of AWS, they are ready for it. If storage fails, they are ready with the backup storage. Immediately the services will be up for the customer will not have any issues, right? The fourth pillar is your performance, which is go global in minutes, which means you can just go create machines anywhere in the globe. Use serverless architecture. Now, this is another fantastic feature. When I say, we have spoken about PaaS, platform as a service, which is nothing but you have a machine, but the machine is maintained by AWS. You have an operating system and stuff, blah, blah, blah. But serverless architecture is one step more, where okay, why did this? What is this? Okay, I'm talking about this. So serverless architecture is basically saying, hey, so serverless architecture is basically saying that it's not a dedicated server, but you can still get your code running. So you will be charged only for the time duration that code runs, whatever code you're giving to the AWS. That's a great flexibility. And finally, the most critical component, security. It is AWS has enabled traceability, which means you can trace back what has been done, right? You have a security in all layers, which means you can apply security at data layer, network layer, your access layer. What access layer? It could be the machine access layer or the AWS portal access layers. So you have security every layers, okay? And AWS can also help you with best best practices of security. You're protected on the transit of the data and the data at rest. Okay, so this is pretty much which I wanted to talk today. Okay, now let me just open up things for the questions. Let me see if this link opens up for the questions. Okay, I have only 7 questions. Okay. I do have some questions in the chat. Let me just quickly pick it up. If you have questions, guys, kindly put it here. It gives me yes, public cloud service is basically providing it for the whole bunch, like a Google Drive. Yes. What is the difference between public and private? Public is basically shared. The same infrastructure is shared between multiple people, where for the private cloud, it is not shared. It is specifically for that organization. Okay. Not sure whether the PPTs will be shared, but definitely the videos would be shared. I see a common question there. Okay. The first question in the Excel sheet, is there a limit to number of virtual machines that can be provided at once by the data center? Good question. In my personal account on AWS, I have tested this for 200 machines in one shot, and it worked, which means I am not part of the company, understand that, and I'm using my individual account, and I'm able to create 200 machines at one shot. So you can understand there's literally no limits as such. Even if there is a limit, you can actually send out a mail to the support team. They're very friendly, they're very responsive, they revert to you on a very immediate basis. They'll help you resolve your resource limit issues very quickly. No limit as such, and can contact customer care if there is an issue. Okay, share, yes. Are you sharing the recording? Yes. What is mean of high availability? It is 11 times 9 or 5 times. What is that? I didn't understand the question. Second part of it. But what is high availability? In simple terms, a service cannot just go down. Okay. Say for example, I am running a portal. Okay. And I am a customer. I'm a customer for AWS, but I have my own customers who are using my web services. There are around 1,000 customers. This web server cannot go down. What will I do? I will create a high availability. How? I'll create 2 web servers, one in data center 1, one in data center 2. This way, even if one data center dies of AWS, I still have my services running. That's your high availability, Pratik. Okay. Rakesh, The next question, is this training available to brush up the training again and again? Is this training again? I didn't understand the question. So basically the recording you're asking, yes. Are you going to share the PPT or slides? I don't think so, Khan. That's going to be possible. I think the recording is good enough for you to go through. PPT slides will not make any sense because it's all animations. So I can probably share some, possibly, if possible. We can put some notes in that YouTube channel, but that's not guaranteed. I can try. Next, Veera, the question, Zen and Nitro hypervisor concept, bare metal concept. Okay. Policy generator condition, edge locations. Okay, fair enough. Zen, what is Zen? It's basically an hypervisor. I'll come back to you, Vinod, on that question. So Zen is basically an hypervisor, which is maintained by Citrix. Basically an open source. In fact, Zen hypervisors are the one, which Red Hat took up. They customized it. Since it is an open source, they customized it. Oracle also took up. They customized it, and they have their own hypervisors. Nitro, in my sense, it is instance type in AWS. Bare metal is something where there is no hypervisor. We install the operating system directly on the hardware. Cloud can provide that as well. Good point, Veera. Policy generator conditions, a very generic term. I still don't understand your question. But on the edge locations, basically these are extended arms of that particular data center, where it's a tiny data centers which will connect back to one main data center, right? Which will take up the connections from the customer. Question next: how does the DevOps engineer communicate with dev for changes? Or they just test and release? So there's always a continuous integration. So when we spoke about DevOps, we spoke about agile methodology. Agile methodology also comes with a Scrum calls. What is Scrum calls? A daily call where the developers, engineers, the DevOps engineers, everybody is going to be on the call just to make sure, is there a blocker? Do we really need to work together to get things done? Do we need anybody's help? So that Scrum call, which is a 15 minutes call, 20 minutes call, will give us a great flexibility to know, is there a roadblocker, instead of coming to the last of the project or somewhere end of the month and say, hey, I'm blocked because of the DevOps guy, or the DevOps is blocked because of the developer, right? There's a continuous coordination which is happening, communication which is happening, and the testing happens together, release happens together. Yeah. No questions here. Okay, next. I have 1 year of experience almost working on SQL. Should I learn AWS DevOps or first get some experience in industry? How will you get experience without learning AWS DevOps? Who's going to give you a job? So you should know at least some concepts, right? Would somebody give you just a job saying that I want to work on AWS, but I have only SQL? Doesn't make any sense. I would definitely not take you, right? So the thing, if you think logically, at least you need to go through the AWS and DevOps concept, understand practical stuff, how things are, even if you want to crack the interview. And without cracking the interview for that, you're not going to get the job for that, right? Okay, so I'm kind of marking these things, whichever I have answered, with a light green color. Okay. Designation, entry level job, DevOps job designation. How does a designation matter? And end of the day, you need experience. Yeah, you may get it as cloud engineer, system administrators, entry level. Those are all entry level. So coming back to the chat, there's no language dependency, but if you want all the operations as a code, you can use Terraform. Yes. Rajesh, thanks for that reply. You're right. Virtual machine, Vinod asked. It is IaaS, right? Yes. Virtual machine itself is an infrastructure as a service. VM is without OS. Okay, now that's a good question. VM without OS, possible. VM with OS is also possible. So it depends on the cloud providers how they really want to manage that stuff. Okay, they might give you just a base OS which will not have latest patch or anything. VM is storage, of course, storage, compute, and network, absolutely. But you will get some base OS. How do you install it? There's no option to install. It's a ready-made image which you get. Okay, Balakrishna, how many tools do we need to learn to be an DevOps engineer? Depends on a number of years of experience. If you're if the industry looks at you like a 2 to 3 years experience, yeah, a couple of DevOps tools are more than enough. But you should know all the DevOps tools. But you should know properly hands-on experience with 1 or 2 DevOps tools. But you still need to know all the 8 or 9 DevOps tools, how they are integrated, what could happen. Okay. Okay. What is the use of VM without OS? That's exactly the point. That's a very rare case. I don't think any cloud providers are providing that today. But what do they do is they'll say, hey, I'll not give you an empty VM, which is not possible. I'll give you some base image, base Windows, base Linux. You upgrade it. Okay, you put a patch, you put whatever software you want, you do whatever you want. Even the operating system which I'm installing and giving it to you, I'm not going to maintain it. It's all yours, right? That's your infrastructure as a service. Tulasi, what could be the day-to-day tasks, responsibilities of DevOps engineer? Another good question. Yeah, you could, not every time the resources has to be created. So you would maintain the resources which is created. You will maintain, you will get alarms. You have to handle those alarms. Figure out if there is a disk utilization. You might have 1, 2, 3, 4 things to do. CPU utilization. You have 1, 2, 3, 4. You have to intimate somebody. Some service has gone down. You have to intimate. It's an operations work. Okay. You will also get into some kind of coding work, which is called as DevOps development or cloud development, right? So that's your day-to-day activity. Working on AWS also, can I continue on AWS or should switch to DevOps? So there's nothing called a switching to DevOps, Karthik. It's more of an enhancing stuff from AWS to DevOps. You don't switch to DevOps, okay? Even if you switch to DevOps today, you should know a cloud. And AWS is one of the best cloud to know in the industry. So you don't switch to DevOps, you upgrade or upskill yourself on the DevOps. That's how you should look into it. Do we need to have a deployment experience, development experience to work on DevOps? No, not exactly. I would not say development experience, but you should have a logical thought process. You might need to do scripting, which is also required. Parth, is it possible of AWS DevOps work remotely? Yes, of course, most of the things are remote today. I'm not too sure. I don't know what to comment, but yes, there are works which you can do remotely. I think VM is also without OS. We should connect to it using PuTTY. So when you're connecting with PuTTY, you need an operating system, which is Linux, basically. So there would be a base image. If you're doing it through web, which means you still have much more better image there, right? SOC tools, yes. Shell scripting is okay, or shell scripting is okay. Python is also great. So taking up the next question, Manikanta, can we find AWS DB to ETL tool and AWS users, which, yeah, you can do that. Is there any language separate for AWS? ETL tools is a common language. And what is the difference between EC2? EC2 is basically a virtual machine. S3 is a storage space where you store files and folders, right? And Smith, um, I have used to create AKS by use Rancher for management and use Jenkins to deploy. Now I want to AWS, what skills I have to learn. So there is something called as, yeah, of course, the AWS DevOps concept, which covers, there's a nice course content around that. So which also covers to an extent on the containerization and stuff. It will also help you understand how it is supposed to be deployed on the DevOps tools. Hypervisor and Docker, these are two different worlds completely. Hypervisor is something making sure on a single hardware I can run multiple operating system. Okay, and Docker is running multiple container on a single virtual machine. It might sound similar, but these are two different things, two different worlds altogether. Policy generator, add statement conditions like principal AR and like that. So Satish, okay, I think you got back on the question. No. So policy generator, yes, you can have IAM policy generators. You can have principal ARMs. We can do a lot more with the help of IAM policies and configure it. Okay. Should I learn right now with current experience, or should I keep on working on current position after having some experience then learn? Now, Pratap, that's a very tricky, I mean, I would not say even tricky question. It's depends on your interest. If you really want to move into AWS, you have to learn AWS first. As simple as that. Yes, we would have some kind of a hands-on session, which I'll showcase maybe tomorrow, a little bit on the security. Day 3, definitely we're going to have. Day 4, yeah, kind of I've planned something. Let's see how far it works. Okay, coming back, I do have few more minutes before we close this. So if you have any questions, please add it to the Excel sheet. Prerequisites for learning AWS and DevOps. Nothing. Your interest? Yeah, DevOps, yes. I guess for DevOps, you need Linux basic commands. It doesn't take more than a day or two to get hold of it. And one important thing is your rigorous practice. Trust me, it is not a thing saying that you just do it, learn it once, you know it, everything. No, it'll clean up. I mean, it'll just disappear from your mind after 2-3 days. It's all a new, fresh concept. Without regular practice, you're not going to be there. Cloud engineer, solution architect, and other engineers works only on cloud services, like only in AWS. No, AWS, Azure, Google Cloud, whereas DevOps works with Docker, Kubernetes, Linux. That's not the case. Cloud engineers would also do DevOps work. Solution architects would. What will they just do with AWS? Today, it is without automation, there's nothing, right? So we AWS with DevOps, cloud with DevOps is an automation, and that's a need of the hour. Non-IT working professional want to switch into DevOps engineering. Yes, Subin, it is possible, but as I said, take it slowly. Don't hurry up. Don't try to compare yourself, saying that the other guy got into in 2 months. Even I want to do. That's a very big mistake you guys will do. Take it slowly for non-IT guys. Start from basics, Linux, get into DevOps, or you can even get into AWS. Take a deep breath. Go in a slow pace. Understand each and everything, and you can be there. Because I've seen personally people coming from mechanical background, taking slowly things, they're able to cope up and do it. So I'm sure it's not going to be too much of an headache. Okay, I probably have a couple of more questions, last questions. So, is there any coding required for the DevOps engineer? You may end up doing coding in Bash scripting. And now, off late, I've seen a lot of requirement with Python. That's not compulsory. Even client understand that it's pretty tough to know Python, DevOps, AWS. It's not that easy. Difference between solution architect, DevOps, and cloud engineer. Solution architect is a person who's going to architect the design based on the knowledge they have about the service components. And DevOps is basically who's going to work rigorously on the DevOps tools. Cloud engineer usually works on the cloud, like creating a resource, managing the resource, managing the permissions for the resource and stuff. Scripting knowledge, yes. Shell scripting, kind of. I've seen um, people being asked on shell scripting most of the times if you say you are a DevOps engineer. Good question, Dipendra. This security thing is managed with the help of tools like SonarQube. We have Tenable. Microsoft have their own security tools. So with these tools integrated in the CI/CD pipeline, we can actually minimize the breaches, control the security issues. Upfront, we can detect, tell the developers to fix that, and stuff. Degree students like BSc computer science students eligible for the DevOps. Yes, definitely. You're a degree holder. There's absolutely no doubt, Veera. You guys are definitely eligible. How much content will get covered in 8 hours of session? I think you guys have the course flow. Tomorrow we are going to touch base on the security components. See, understand this is just 8 hours, and I'm sure you can understand that 8 hours we cannot just digest everything. This is to give you an overall view of what is AWS and DevOps, what are the components which you need to look for more. So tomorrow I'm going to talk about security as well. What is the security? And then the third day I'm talking about a lab, actually, a basic lab on the AWS part, how the networking works, how the basic networking is set up, and how the EC2 instance is set up, what is basic networking. Basic networking is one thing which I recommend everybody to go through. The reason I strongly believe that is I have grown from there, and I have seen a great advantage if you guys have a basic networking understanding. So that's why I planned for day 3 on basic networking with networking concepts on AWS and create a machine. So you'll get a full 360-degree view of how a basic machine is created, how do you log into it, and stuff. I don't think so. After this is just a workshop. I don't think you'll get a certificate for this. DevOps. So this is pretty much the last question which I'm taking up. As a part of DevOps job, how much AWS should be used compared to DevOps tools? See, that's not your choice, right? That's customer's choice. We as an engineer should be ready for whether the customer wants to deploy things only via AWS, we should be ready for that. Only via DevOps with in-house tools, we should be ready for that. That's our job. Okay. We cannot decide saying that, okay, it is always going to be like AWS and we'll have 40% of AWS, 60% of DevOps. No, absolutely not. It really depends on projects, how things are going to be. But we as an engineer should be ready for anything. Maybe the customer project, the first 3 months was different. The next 9 months is going to be completely different. As a DevOps, if you take up just the DevOps itself, it's almost a 2 months course. You have 9 modules, 9 or 10 modules with labs and stuff. Right, great. Thanks everyone. I think it was a great session. Thanks for being very interactive. And let's connect tomorrow, same time, and let's see how far we can go.